In this video, we're going to learn how to use the Darling model kits to build models of organic molecules. So if you bought a brand new Darling model kit, you should see a lot of pieces that look like this one, or you might see pieces that look like this with different color, things like this, and so on and so forth. So you should have a lot of black kind of wedged pieces like this one right here. If you look closely right here, there should be some raised lettering that says SP3. And so the idea is you're supposed to take all of the black halves and you should just go through right now and pair all of them up. And when you pair up these pieces, what you're really doing is you're building a tetrahedral sp3 carbon atom. And so just to show you, when you do this, you want to kind of, this is still loose. It should click together pretty hard and kind of snap to the point that you kind of see the two pieces are really interlocked together. So go through and do that with all of your black sp3 pieces. Make a bunch of tetrahedral carbons. You don't need to do the same thing right away, but the same thing can be done with these red pieces. Red is conventionally for oxygen, and blue will conventionally be for nitrogen. So I'm going to leave this here for now. The way the model kit handles sp2 carbons is using these gray pieces, and just make sure that the gray piece says sp2 right here. There's another gray piece that says sp3, which we'll get to later. So as you know, an sp2 atom should have three things coming off of it. And so right here, this sp2 kind of piece already has two of them. And so the way the Darling model accounts for the third piece is to just have a built-in pi bond like this. So this is a pi bond, and our piece is supposed to kind of just snap in here. Now if I get a second piece and I want to complete this carbon-carbon double bond, an important thing to do is when you put it in, don't line up these kind of nubs the same way. Your life will be a lot easier if you go through and make all of these double bonds like so. So having the nubs pointed the opposite directions, snapping it together like that. For the triple bond, that's just kind of a self-built piece that looks just like this one here. And so this is trying to show you that there is a pi bond right here and a pi bond right here. Right? Those are the two pi bonds of the triple bond. I think it's helpful to think about what these models mean just as is. These are complete molecules, so the way we're supposed to interpret them is to say that this is the vertex, which is a carbon, and off of the four directions here, if there's nothing else attached, we treat these as hydrogens if it's a carbon atom. Right? So this is really a molecule of CH4. Same idea here. So if we have these two kind of vertices, this is a 2-carbon molecule, 1, 2, 3, 4 hydrogens coming off either end. That should be then this molecule here, ethene, or ethylene more formally. Finally, when we look at the triple bonded version, again we have 1 carbon here, 1 carbon here, nothing else is attached at the either end. This makes this molecule like that. That's acetylene. Okay, now let's try to put some oxygens into our molecules. Let's start off by building this molecule right here. This is formaldehyde. And so what you have in here is a carbon-oxygen double bond. And so for our thinking, that means we need kind of an sp2 carbon piece and an sp2 oxygen piece. So let me lay out these pieces all right here. So we have sp2 piece right there. We need an sp2 piece for the oxygen on the top there. And then we need to make that double bond. But in this case, we don't want to use this double bond piece because this is color-coded to be carbon and carbon. So these are kind of two halves of carbon. We actually want to use the pieces that come like this. So the models, there are these kind of half pi bonds that look like that. So that way, if we clip these all together, then we can get to a pi bond that accurately shows that it is kind of half from the carbon, half from the oxygen, like that. And so if you're looking at this model, what you should see then is that we have, again, a carbon atom right here, nothing attached here, so those are two hydrogens now. We have our oxygen, that's sp2, and since there's nothing else attached here, these are going to now become lone pairs on the oxygen atom. Okay, one final thing about this model kit. So if you're looking through it carefully, you might see a piece that looks like this. So it's kind of a shiny silvery color, and it's labeled sp3 still. And so this is a special piece because it's made of a more flexible plastic. And so its purpose is to allow you to make really small ring sizes. So for example, if you try to build these rings, what you'll find is that as the rings get smaller and smaller, especially really the 5-membered ring will be okay, but as you go to 4 and 3, those will start to really put a strain on the regular sp3 pieces. And so the idea is that you should set up one of your carbons to be, your sp3 carbons, to incorporate this flexible silvery piece so that it can be used. So you want to take advantage of this flexible piece to make smaller ring sizes. So I'm going to try to build a 3-membered ring here, and like even then it's a bit of a stretch, but you can kind of see that this piece is doing the bending for us.